We know that the general form of a quadratic equation is ax squared plus bx plus c equals 0. If I divide through by a, this equation becomes, I know that 0 over a is still 0. This equation becomes x squared plus b over ax plus c over a equals 0. Now let me call this equation 1. If alpha and beta are the roots of this equation, then that simply means if I solve the equation, I'm going to get x equals alpha or x equals beta. Alpha and beta are just representations. And this simply means x minus alpha equals 0 or x minus beta equals 0. And I can write that as x minus alpha times x minus beta equals 0. Now, if I expand the brackets here, what do I have? X squared minus beta x minus alpha x plus alpha beta equals 0. Now, I can write this as x squared minus x into bracket beta plus alpha beta equals 0. Now let me write it, let me make it look nicer by writing it this way. Minus beta plus alpha is the same as alpha plus beta times x. You know, you don't say x2, you say 2x. So that's why I'm rewriting this as this. Plus alpha beta equals 0. Now if I call this equation 2, I now want to compare equations 1 and 2. This is equation 1 and this is equation 2. If I compare the two equations, equation 1 is x squared plus b over ax plus c over a equals 0. That's equation 1. While equation 2 is x squared minus into bracket alpha plus beta times x plus alpha beta equals 0. Equals 0. That's equation 2. Now if I compare equations 1 and 2, if I compare coefficients in equations 1 and 2, the coefficient of x in equation 1 is b over a, and the coefficient of x in equation 2 is minus alpha plus beta. That means minus alpha plus beta is equal to b over a, and that simply means alpha plus beta equals minus b over a if I multiply through by minus 1. And if I compare the constants in the two equations, the constant in equation 1 is c over a, and the constant in equation 2 is alpha beta. That simply means alpha beta equals c over a. Alpha beta equals c over a. And this simply tells us that the sum of roots, alpha plus beta represents sum of roots, while alpha beta represents product of roots. Product of roots. That simply means if alpha and beta are the roots of a quadratic equation, the sum of those roots is given by minus b over a, and the product of those roots is given by c over a. And we know that a, b, and c are from the general form of a quadratic equation, which is written in the form ax squared plus bx plus c equals 0, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant. Now, let's write a few identities for the roots. I can also say that the quadratic, the equation x squared minus alpha plus beta times x plus alpha beta equals 0 is also a representation of the general form of a quadratic equation, where alpha plus beta is the sum of the roots and alpha beta is the product of the roots. In other words, you can write a quadratic equation in terms of its roots as x squared minus sum of roots times x plus product of roots. Can I write that on a single line? You can write a quadratic equation in terms of roots in its general form as x squared minus sum of roots times x plus product of roots equals 0. That's the general form of a quadratic equation in terms of its roots. Now let's take a few examples. Find the sum and product of the roots of the following equations: a 2x squared minus 3x minus 1 equals 0, and b half x squared minus 3x minus 1 equals 0. Now let's go to the solution. A, the equation is 2x squared minus 3x minus 1 equals 0. And that simply means a, which is the coefficient of x, is equal to 2. A, which is the coefficient of x squared, the coefficient of x squared is equal to 2. And b, which is the coefficient of x, is minus 3, while c, which is a constant, is minus 1. Now, let alpha and beta be the roots of the equation. And that simply means the sum of the roots, which is alpha plus beta, is minus b over a. And that's equal to minus, b is already a negative value, so you have to remember that, minus into bracket minus 3 over a, which is 2. And that simply means the sum of roots alpha plus beta is 3 over 2. Now product of roots, that will be alpha beta, is given by c over a, and that's equal to c is minus 1 and a is 2. That's equal to minus 1 over 2. Now let's take the second question. The second question is half x squared minus 3x minus 1 equals 0. The equation is half x squared minus 3x minus 1 equals 0. And that simply means a is 1 over 2, b is minus 3, and c is minus 1. Don't forget, a is the coefficient of x squared, b is the coefficient of x, which is minus 3, and c is the constant, which is minus 1. This is minus 3. Now, let alpha and beta be the roots of the equation. That means the sum of the roots is alpha plus beta, and that's given by minus b over a, which is minus into bracket minus 3 divided by a, which is 1 over 2. And that simply means plus 3 divided by 1 over 2. And that's the same as 3 times 2 over 1, which is 6. And the product of roots is alpha beta, and that's given by c over a, which is c is minus 1 and a is 1 over 2. That simply means minus 1 divided by 1 over 2, which is the same as minus 1 times 2 over 1, which is minus 2. And that's it. Very, very simple. Now, let's find a few identities for some relationships between the roots. For example, let's see let's find an identity for alpha square plus beta square. You can find an identity for the relation alpha square plus beta square. And how do we do that? Let's start from the square of the sum of alpha and beta. The square of the sum of alpha and beta is the same as alpha plus beta times alpha plus beta. And that simply means alpha into bracket alpha plus beta into bracket alpha plus beta. And this is the same as alpha square plus alpha beta. Beta times alpha can be written as alpha beta plus beta square. And this is the same as saying alpha square plus alpha beta is 2 alpha beta plus beta square. And we can see now we can write this as alpha square plus beta square plus 2 alpha beta. This simply means, let me write that well. This simply means the square of the sum of alpha and beta is the same as alpha square plus beta square plus 2 alpha beta. Now, if I make alpha square plus beta square the subject of this formula, I'm going to have alpha square plus beta square equals alpha plus beta all square minus 2 alpha beta. That's simply bringing 2 alpha beta to the left hand side, and it becomes minus 2 alpha beta when you do that. So you are going to have alpha square plus beta square equals alpha plus beta all square minus 2 alpha beta. And that's the identity for alpha square plus beta square. So let's find another one for alpha square minus beta square. Of course, this is a difference of 2 squares. This is the same as alpha plus beta times alpha minus beta. Now, I need to know what alpha minus beta is, and I can obtain that from the square of alpha minus beta. The square of alpha minus beta is the same as alpha minus beta times alpha minus beta, and that's the same as alpha into bracket alpha minus beta into bracket alpha minus beta, which is equal to alpha square minus alpha beta. Now here, minus beta times alpha, I can write it as minus alpha beta 2, and then minus beta times minus beta will be plus beta square. And that simply means alpha square minus alpha beta is minus 2 alpha beta, and then I have the plus beta square. Now, this is the same as, I already know this is the same as alpha square plus beta square minus 2 alpha beta. But I just obtained an identity for alpha square plus beta square, which is, let's check that again, which is alpha plus beta all square minus 2 alpha beta. So instead of writing alpha square plus beta square, that's what I'm going to write. I'm going to write alpha plus beta all square minus 2 alpha beta, which represents alpha square plus beta square, and then the minus 2 alpha beta minus 2 alpha beta. And this simply means alpha plus beta all square minus 4 alpha beta. Don't forget that that's the identity for alpha. That's the identity for the square of alpha minus beta. So that simply means alpha minus beta all square is equal to, I need to make that clearer. That simply means alpha minus beta all square is equal to alpha plus beta all square minus 4 alpha beta, which therefore means alpha minus beta itself will be equal to the square root of the whole of this. That is square root of alpha plus beta all square minus 4 alpha beta. It looks a bit tricky, but you'll be able to remember it if you can just derive it yourself. You really don't need to memorize it. So that therefore means alpha square minus beta square, which is the same as alpha plus beta times alpha minus beta, is equal to alpha plus beta times square root of alpha plus beta all square minus 4 alpha beta minus 4 alpha beta. And that's the identity for alpha square minus beta square. Very, very simply. Now let's take a few more identities. We remember that a cube minus b cube, or let me do a cube plus b cube, is the same as a plus b times a square minus ab plus b square. If you expand this, you are going to get a cube plus b cube. So that simply means alpha cube plus beta cube will also be the same as alpha plus beta times alpha square minus alpha beta plus beta square. And that's the same as alpha plus beta times alpha square plus beta square minus alpha beta. That's just rearranging the whole of this. And what does that mean? Alpha plus beta times, I know that alpha square plus beta square is alpha plus beta all square minus 2 alpha beta. So I'm going to write that as alpha plus beta all square minus 2 alpha beta. And I'll put the minus alpha beta. Now, what do we have next? That simply means alpha plus beta times alpha plus beta all square. I want to write it this way: alpha plus beta all square minus 3 alpha beta. I know that minus 2 alpha beta minus alpha beta is minus 3 alpha beta. So that is the identity for alpha cube plus beta cube. Alpha cube plus beta cube equals alpha plus beta times alpha plus beta all square minus 3 alpha beta. That's the identity for alpha cube plus beta cube. Now let's check alpha cube minus beta cube. Alpha cube minus beta cube, I can write that as alpha minus beta. That's the same as alpha minus beta, or maybe we should write a cube minus b cube first. A cube minus b cube is the same as a minus b times a square plus ab plus b square. A square plus ab plus b square. So that simply means alpha cube minus beta cube will be equal to alpha minus beta times alpha square plus alpha beta plus beta square, and that's equal to alpha minus beta into bracket. Okay, let me write before that step, let me write it as alpha square plus beta square plus alpha beta. That's just a rearrangement of the whole of this, and that's equal to, I know what alpha minus beta is. If you remember, alpha minus beta, let's go find that. Alpha minus beta is alpha plus beta all square. No, alpha minus beta is the square root of alpha plus beta all square minus 4 alpha beta. So that's what I'm going to write. Square root of alpha plus beta all square minus 4 alpha beta. Square root of alpha plus beta all square minus 4 alpha beta. And I know that alpha square plus beta square is alpha plus beta all square. It will be better to write it this way. Alpha square plus beta square is alpha plus beta all square minus 2 alpha beta. And you have another plus alpha beta, and you can close the bracket, plus alpha beta, and you can close the bracket there. You can close the bracket that way. Now, what do we have? What do we have next? That simply means square root of alpha plus beta all square minus 4 alpha beta times alpha plus beta all square minus 2 alpha beta plus alpha beta is minus alpha beta. And that's the identity for alpha cube minus beta cube. That simply means alpha cube minus beta cube is equal to the square root of alpha plus beta all square minus 4 alpha beta times alpha plus beta all square minus alpha beta. And that's it. Very, very simple. You really don't need to memorize them. You can always derive them yourself. If the roots alpha and beta of the equation px squared plus qx plus r, where p, q, and r are constants, the equation is px squared plus qx plus r equals 0, and its roots are alpha and beta. If those roots are such that alpha is equal to 4 beta, show that 4q squared is equal to 25p r. First of all, the sum of the roots is alpha plus beta, and we know that that is minus b over a. Alpha plus beta equals minus b over a, and from this equation, a is p, b is q, and c is r. A is the coefficient of x squared, which is p, b is the coefficient of x, which is q, and c is a constant, which is r. So that means alpha plus beta is going to be minus q over p. And we know that alpha is equal to, we were told that alpha is equal to 4 beta. That simply means alpha plus beta is going to be the same as 4 beta plus beta. That means 4 beta plus beta is equal to minus q over p, which simply means 5 beta equals minus q over p. And that simply means beta is equal to minus q over p divided by 5. And that's the same as minus q over 5p, because that actually means minus q over p times 1 over 5. So that's beta. Now the product of the roots, which is alpha beta, is c over a. And we can see that c is r and a is p. So that simply means alpha beta equals r over p. If alpha beta equals r over p, and we know that alpha is the same as 4 beta, That simply means 4 beta times beta is equal to r over p, which means 4 beta square is equal to r over p. And that simply means beta square is equal to r over p divided by 4, which means beta square equals r over 4p. Of course, you know this means r over p times 1 over 4. So that therefore means beta itself will be the square root of r over 4p. And what does that mean? That simply means square root of r. Okay, or let me leave it that way. Now I have two definitions for beta. Beta equals minus q over 5p, and at the same time beta equals square root of r over 4p. That simply means minus q over 5p is equal to the square root of r over 4p, because they both represent beta. So that's what I would say. That means minus q over 5p. Let me write it this way first. Beta equals minus q over 5p, and that same beta is also equal to the square root of r over 4p. So that therefore means minus q over 5p is equal to the square root of r over 4p. That means minus q over 5p is equal to the square root of r over 4p. Now if I square both sides, that simply means q square will be over 25p square. What I'm doing is I'm squaring both sides. Q square over 25p square will be equal to r over 4p. Now if I cross multiply, what do I have? If we do cross multiplication, that simply means 4p q square is equal to 25p square r. 4p q square equals 25p square r. 4p q square, if we cross multiply, is equal to 25p square r. That's it. 4p q square equals 25p square r. And they said we should show that 4q square is equal to 25pr. So if I divide through by p, I'm going to have 4q square equals 25pr. And that's the proof, very, very simply. The roots of the equation x squared plus mx plus 11 equals 0 are alpha and beta, where m is a constant. The equation is x squared plus mx plus 11 equals 0, and its roots are alpha and beta. If alpha square plus beta square plus beta square equals 27. Find the values of n. First of all, from the given equation, x squared plus mx plus 11 equals 0, a is the coefficient of x squared, and that's 1. B is the coefficient of x, which is m, and c is a constant, which is 11. So alpha plus beta is equal to minus b over a, which is minus m over 1. And alpha beta is c over a, which is c is 11 and a is 1. So that means alpha beta equals 11 over 1, which is 11. Now alpha square plus beta square is equal to alpha plus beta all square. Alpha plus beta all square minus 2 alpha beta. And we already know that alpha square plus beta square is 27. So that simply means alpha plus beta all square minus 2 alpha beta equals 27, because this is alpha square plus beta square. Now, what is alpha plus beta? That means alpha plus beta, which is minus m over 1, and that's minus m. That means minus m squared minus 2 times alpha beta is 11 minus 2 times 11 equals 27. And that simply means m squared minus 22 equals 27, which simply means m squared equals 27 plus 22. If you move minus 22 to the right hand side, it becomes plus 22. And that simply means m squared equals 49. And if you find the square root of both sides, m equals square root of 49, which is plus or minus 7. That simply means m equals plus 7 or m equals minus 7. And that's it. Very. The roots of the quadratic equation 3x squared plus 2x minus 5 equals 0 are alpha and beta. Find the value of 1 over alpha plus 1 over beta. The quadratic equation is 3x squared plus 2x minus 5 equals 0. And its roots are alpha and beta. Find the value of 1 over alpha plus 1 over beta. 1 over alpha, let's do this first of all. From the equation, a is the coefficient of x squared, which is 3. B is the coefficient of x, which is 2. And c is a constant, which is minus 5. So, how do we find the value of 1 over alpha plus 1 over beta? 1 over alpha plus 1 over beta is the same as the LCM is alpha beta. Alpha beta divided by alpha is beta. That's beta plus alpha beta divided by alpha. Let me get that straight. Alpha beta divided by alpha is beta. Beta times 1, that's beta. Now, alpha beta divided by beta is alpha. Alpha times 1 is alpha. So the numerator is alpha beta plus alpha. And now to the next step, which will be equal to, I can write beta plus alpha as alpha plus beta over alpha beta. And I know that alpha plus beta is minus b over a, which is equal to b is 2 and a is 3. That will be minus 2 over 3. While alpha beta, which is given by c over a, is equal to c is minus 5 and a is 3. That will be minus 5 over 3. Minus 5 over 3. That therefore means 1 over alpha plus 1 over beta is equal to 1 over alpha plus 1 over beta, which is alpha plus beta over alpha beta, will now be alpha plus beta. That's minus 2 over 3. That's minus 2 over 3 divided by alpha beta, which is minus 5 over 3, divided by minus 5 over 3. And that's equal to minus 2 over 3 times 3 over minus 5, which simply means, of course, 3 here 1, 3 here 1. Minus 2 divided by minus 5 is 2 over 5. And that's the value of 1 over alpha plus 1 over beta. Take another example. Given that alpha and beta are the roots of 3x squared minus 7x plus 4 equals 0, find the quadratic equation whose roots are 1 over alpha and 1 over beta. The quadratic equation is 3x squared minus 7x plus 4 equals 0, and its roots are alpha and beta. Now we want to find the quadratic equation whose roots are 1 over alpha and 1 over beta. First of all, a is the coefficient of x squared, which is 3. B is the coefficient of x, which is minus 7. And c is a constant, which is 4. So we can find the sum of the roots, which is alpha plus beta, and that's minus b over a, which is minus into bracket minus 7 over a, which is 3, and that is 7 over 3. And we can also find the product of the roots, which is alpha beta, and that's given by c over a, which is 4 over 3. C over a equals 4 over 3. Now, to find the quadratic equation whose roots are 1 over alpha and 1 over beta, this is what we do. We add the roots. The sum of the roots is 1 over alpha plus 1 over beta, and that is the LCM is alpha beta The LCM is alpha beta. Alpha beta divided by alpha, that's beta. Beta times 1 is beta, plus alpha beta divided by beta is alpha. Alpha times 1 is alpha. And that simply means alpha plus beta. Of course, I can write beta plus alpha as alpha plus beta. That simply means alpha plus beta over alpha beta, which is equal to alpha plus beta is 7 over 3. And that means 7 over 3 divided by alpha beta is 4 over 3 divided by 4 over 3. And that simply means 7 over 3 times 3 over 4. 3 here 1, 3 here 1, and that is 7 over 4. Just leave it as a fraction like that, 7 over 4. Now, the product of the roots, the roots of the new equation are 1 over alpha and 1 over beta. So, the product of those roots is 1 over alpha times 1 over beta, and that's 1 over alpha beta, which is equal to 1 divided by alpha beta. We already found that is 4 over 3. That's 1 divided by 4 over 3. And that simply means 1 times 3 over 4, which is 3 over 4. Now we know that with a quadratic equation can also be written in the form x squared minus sum of roots times x plus product of roots equals 0. This is also a representation of a quadratic equation in terms of its roots. So the equation whose roots are 1 over alpha and 1 over beta is x squared minus the sum of the roots 1 over alpha plus 1 over beta, which is 7 over 4. Let's see that. That's 7 over 4. That will be x squared minus 7 over 4 times x plus product of the roots. The product of the roots are 1 over alpha and 1 over beta. The product of those roots is 3 over 4. That's plus 3 over 4 equals 0. This is how to find a quadratic equation when its roots are given. And what do we do here? This is the same as just saying x squared minus 7 over 4x plus 3 over 4 equals 0. Now, to clear the fractions, I can multiply through by 4. If I multiply through by 4, that simply means 4x squared minus 7x plus 3 equals 0 is a quadratic equation whose roots are 1 over alpha and 1 over beta. And that's it very, very simply. Now, if alpha and beta are the roots of the equation 2x squared plus 5x minus 6, the equation is 2x squared plus 5x minus 6 equals 0. Find the equation whose roots are alpha minus 2 and beta minus 2. Okay, first of all, let's find alpha plus beta and alpha beta. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is 5. And C is a constant, which is minus 6. Now, alpha plus beta is minus b over a, which is minus 5 over 2. And alpha beta is c over a, which is minus 6 over 2. Minus 6 over 2. And that's minus 3. Now, we want to find the equation whose roots are alpha minus 2 and beta minus 2. The first thing to do is to find the sum of those roots. The sum of the roots is alpha minus 2 plus beta minus 2. And that's equal to alpha plus beta minus 4. Minus 2 is minus 4. And that simply means we already know alpha plus beta. That's minus 5 over 2. That's minus 5 over 2 minus 4, which is simply minus 13 over 2. That's minus 13 over 2. Now, the product of the roots, we know the roots of the equation we want to find are alpha minus 2 and beta minus 2. So we're finding the product of those roots. Product, which is alpha minus 2 times beta minus 2, is alpha into bracket beta minus 2. Let me do it this way. Minus 2 into bracket beta minus 2. And that's equal to alpha beta minus 2 alpha minus 2 beta plus 4, which is equal to alpha beta minus 2 into bracket alpha plus beta plus 4, which is equal to alpha beta. We already know that alpha beta is minus 3. So that simply means minus 3 minus 2 into bracket alpha plus beta is minus 5 over 2. So that means minus 2 into bracket minus 5 over 2 plus 4. And where do we go from there? That simply means minus 3, 2 here, 1, 2 here, 1. And when you open the bracket, you have plus 5 plus 4. And that's equal to minus 3 plus 5 is 2. 2 plus 4 is 6. And that means the product of the roots is 6. Therefore, the equation whose roots are alpha minus 2, and beta minus 2 is, we already know that x squared minus sum of the roots. The sum of the roots is minus 13 over 2. That's x squared minus into bracket minus 13 over 2. Sum of roots times x plus product of roots. The product of the roots is 6 equals 0. And that simply means x squared plus, I need to write that well, x squared plus 13 over 2x plus 6 equals 0. Now, to clear the fraction, I can multiply through by 2, and that therefore means 2x squared plus 13x plus 12 equals 0. That's the equation whose roots are alpha minus 2 and beta minus 2. I need to write that x well. And that's it, very, very simply.